Hello. Think about fireworks. I don't know if you've ever had the experience like when I was a kid. You'd set off a firework, you think it's pretty cool. You get a little too close to it, then it almost blows off your fingers. That's an example of an extremely exothermic reaction. And sometimes those can get out of control. Or maybe you're doing a fire pit, and you want to add some stuff and it's just giving off a ton of heat, or maybe it gets a little bit out of control. On the other hand, you might be an athlete. And sometimes, if you get injured, you go off to the sides, and the trainer can have this pack. It's a cold pack, and it's not cold at first, and they snap something inside the pack, and then it gets really cold. Something's reacting. It's taking in heat. We call it endothermic. These have all kinds of applications. So let's take a look at these. What is it about these, and how do these work? That's what we're going to try and do. Okay, so I'm in my home office, and here's my computer. My computer is about 25 degrees Celsius, which you would imagine is room temperature. No big deal. All of a sudden, over here, I'm getting onto something here that's really bright. Now, I opened this up about 15 minutes ago. This is one of the foot warmers. Okay, this I got at Home Depot. It's about 40 degrees Celsius. Here is a package that is unopened that's about 25 degrees Celsius. And then here's the other foot warmer, because again, you have 2 feet and it goes in there. So these things get up to about 45 degrees Celsius. And even when I move it off the desk here, so there's my hand. So compared to my hand, you can see that it's warm, but it's not going to burn me. 60 degrees Celsius and above is where it would really feel uncomfortable. But if I move it, it leaves, you can see the heat that it left behind, right? So this is kind of a cool thing. Let's see if we can figure out exactly how this works. Hey, how's it going? Okay, so one of the things we'd like to look at is that reaction that caused that heat to occur. And we have a great model here on Atomsmith. So there's a couple things here I just want to show you. So first of all, number one is if you look over here, we're looking at a model of iron. Here's an iron atom with no charge on it, okay? And here's some sulfur with no charge on it. And this is before the reaction. Now, why did I pick these two? Well, it just so happens that when we take a look on the back of our little package right here from our, like the little foot warmers, it says that there's iron and oxygen, and with a little bit of salt, and that goes to rust, which is iron oxide, and that supposedly is what's causing this heat. Now, I didn't have a model of iron and oxygen, but I do have a model of iron and sulfur, and if you notice, sulfur is in the same family as oxygen. It's going to behave chemically in a similar fashion. So we're going to run through. Now look over here, this side over here, right here at the reaction pathway. This is the key to understanding exo and endothermic reactions. Both of these elements start off with what we call a heat of formation of 0. Now, to push these together, I'm going to have to climb an energy hill, if you will. But then once they have that exchange of electrons, okay, and we'll see the charge change, it's going to drop way down, and at the end, the final product is going to be down here. And if you notice, it's a lot lower than when it started at. Where did the energy go? It left the system, hence exothermic, and that's the energy that we need to calculate. That's the energy, that's the heat that leaves. It's negative because it left the system. Those chemicals no longer have that energy. Okay, so let's just take a quick look. And the nice thing about this is we can slide through here, and then all of a sudden, right there at the top of the hill, all of a sudden we saw this big, one becomes +2, one becomes -2, and we can see it forms, and there it is. And so you see a big difference here. And it was due to that quick exchange of electrons, heat transfer, you actually get more heat out. That is a model of an exothermic reaction. Our job is to use Hess's law to find those numbers, because if we can control those numbers, we can use that heat to do great stuff. That's the goal.